Alright, in this video I'm going to do two different quotient rule problems. One of them is pretty traditional and one's a little different because you'll have to kind of mix in a graph to figure some things out. So the first problem is we have g of x, which is x plus 2 over x squared minus 3. And the problem that we really want to solve is to find the tangent line at x equals 2. So to do that, I'm going to need the slope. And the slope is going to be from the derivative. So I'll need g prime of x. So g prime of x using quotient rule is going to be the bottom function, which is x squared minus 3, times the derivative of the top, so the derivative of x plus 2 is just 1, minus, it's going to be the top, which is x plus 2, times the derivative of the bottom function, so the derivative of x squared minus 3 is 2x, all divided by the bottom function squared. Alright, and now I will plug in 2, so that's going to give me all of this, and if I simplify that, I end up with 1 minus 16 over 1, which is negative 15, but of course to write the equation of the tangent line I also need the y-coordinate when x is equal to 2, so to find that I plug into the original function, so g of 2 is just going to be 4, so 2 plus 2 over 1. And then I'm going to write my answer in point slope form, which is the form you pretty much always want to use. So y minus 4 is equal to negative 15, the quantity x minus 2. And there you go. So quotient rule is really not that bad, but you do have to remember it. So the next problem is g of x is defined to be radical x divided by 3 times f of x. And f of x, all we really know about it is this graph. So this is a graph of f of x. So I'm going to have to use that to find some values. So what I want to do is I want to find g prime of 4. So before I do that, I'm going to rewrite g of x. So g of x can be rewritten as 1/3 times x to the 1/2 divided by f of x. So radicals are really annoying when you're trying to do calculus, so you always want to change those to rational exponents. And what I'm doing, I pulled the 1/3 out, and I'm going to use the constant multiple rule, so I'm just going to actually find the derivative of x to the 1/2 over f of x, and then multiply the whole thing by 1/3. I could actually leave the 3 in the denominator and treat the bottom function as 3 times f of x. I'll get the same answer if I do that, but then I have this factor of 3 kind of floating around all over the place, and it's just annoying. So I've rewritten it this way. Now let's find the derivative. So g prime of x, it's going to be 1/3 times this giant quantity, and now I'm going to find the derivative. So it's going to be bottom, so f of x, times the derivative of the top. So the derivative of x to the 1/2 is going to be 1/2 x to the negative 1/2 by the power rule, and then minus top, so x to the 1/2. Derivative of the bottom, all we know is just going to be f prime of x, because there's nothing more we can do about that. And then all divided by the bottom, which is f of x, and we want to square it. And close that parenthesis. So now I want to find g prime of 4, but it occurs to me that to do that, I'm going to need to know f of 4 and f prime of 4. So if I look at the graph, I put a point at 4, 2, so that means that f of 4 is 2. And then I'm going to need f prime of 4. Well, if you look at the graph between 2 and 5, between x equals 2 and x equals 5, it's just this line. And lines have a constant slope, which means that f prime on that interval is going to be a constant, and it also turns out to be 2 because the slope of the line is 2. So there are just 2's everywhere in this problem, which maybe I should have thought about ahead of time, but I didn't, so whatever. Now I'm going to plug in. So I always like to rewrite it where I'm showing what I'm plugging in. Some people skip this step. Those people sometimes make mistakes, so try to avoid that. And now I'm going to plug in the values that I found. 4 to the 1/2 would be 2, so 4 to the negative 1/2 is 1/2. That's where that, so we have 1/2 times 1/2. That's where 1/4 is coming from, in case you couldn't follow that. And then if I simplify this, I end up with negative 7 over 24, and I always like to write my final answer and box it if I can. So g prime of 4 is negative 7 over 24. And that's about it. So it's a little trickier, but not really, and if you just kind of be very organized and neat about it, you won't have a problem. Hope you found this helpful, and good luck.